Time is up for the warm-up. Colored pens up. And this is all review of the last lesson. You can see today is lesson 4.3. We are skipping 4.2. Number 1, is it prime or composite? Let's survey the class. Give me a thumbs up if you think it's prime. Put your thumbs down, so I assume if you did not put your thumb up, you think it's composite, and it is composite. Number 2, the number 34, is that prime or composite? Give me a thumbs up if you think it is prime. So I assume since nobody put their thumbs up, everybody thinks it's composite, and that's a good thing because it is. What about number 3, the number 29? Give me a thumbs up if you think it's prime. Some people over here, some people over here. Looks like just about everybody thinks it's prime. That's good because it is prime. We will go over those in a couple of minutes. Number 4. Number 4, 5, and 6, I guess I could have been a little more clear in my instructions. I asked you to try and find the prime factorization without using a factor tree. What I really meant was do the factor tree kind of mentally. I meant don't draw the factor tree. So I apologize if I misled you at all. But either way, I want you to find the prime factorization. So what is it for number 4? We'll start with Natalie, Stephen, Tristan. Okay. Okay. Well, all I'm asking you to do is read your answer off your paper. You volunteered, so it's time to share what's written on your paper, whether it's right or wrong. Okay, so we're on number 4. So the correct answer is 2 to the 4th power times 3. If you wrote 2 times 2 times 2 times 2 times 3, I'll accept it, but this is a better answer when we just have a number. Now, when we have numbers and letters, we don't use any exponents. So let's see what we got for number 5. We'll start with George, Nolly, and then Essence. Okay. Okay, what'd you get, Essence? Okay, so I actually made a mistake when I wrote the answer. So that should not be 3 to the 3rd power. It should be 3 times 3 times 3. So I apologize for that. But it did help me fit in the answer into this space. So it is 2 times 3 times 3 times 3 times x times y times y. What about number 6? We'll start with DeAndre, Adriana, and then Angela.
2 times 2 times 3 times 3 times 3 times 8 times 6 times 8.
Okay. Okay, what'd you get, Angela?
2 times 2 times 8 times 8 times 8 times 8 times 8.
Very good. So again, I used exponents so that I could fit it all in. This really should be 2 times 2, and then 3 times 3 times 3, times A times A times A times B. So, I asked you to try and find the prime factorization without using the tree or without drawing the tree. Let's talk about one part of it, the variables. Let's look at number 6. What is the connection between this and this that would allow you to skip over the tree entirely? And I'm talking about not just like my super high level students, I'm talking about everybody. What's the connection between this and this that allows you to skip over the tree? Fancy?
Because it says A to the 3rd power, but there's 3 A's.
That's right. The exponent right here is telling you how many A's to write down. A to the 3rd power means A times A times A. So you don't need a tree for that. You already know how many A's to write. B is really to the first power, and that's why we have one letter B. X to the second power, there's a 2 X's. Y to the second power, there's a 2 Y's. So figuring out the variables and how many of them to write is really not hard if you can make that connection. Now, the numbers. Let's talk about 54 in number 5. So now I want to focus right here. I asked you to try and do this without a tree, and there is a reason. Okay? There is an important reason. So here is my vision of what's going on. I'm going to model what happens in my head. I take the number 54 and I immediately split it. So now what I'm going to try and change the terms that I'm using. I'm going to start using the word split. Okay? I want to split 54 into 2 factors. So I'm splitting it. And I immediately think of 2 and 27. So this is what's going on in my head. I immediately see 2 times 27 in my brain. Hold on. The 2 is a prime number. So I lock that number in. This number is locked, but 27 is not prime. It can be split again. Now, when I say split, you should be thinking of the branches in the tree, or I just think of the 2 numbers kind of splitting apart. So now I think of the number 27, and I say to myself, okay, what 2 numbers could I split that into? What 2 numbers could I split 27 into? Alexis? 9 and 3. So now what I do is I rewind in my head, and I go, okay, well that's not really a 27, it's really a 3 times a 9. And now I say to myself, okay, well the 2 is locked, and the 3 is locked, but the 9 is not. What can the 9 be split into? Savannah? 3 times 3. So again, in my head, I rewind, and I say, that's not really a 9, it's really a 3 times a 3, and now they're all prime, so now I'm done. Now I've split the number into all its prime factors. So I've done the tree without actually drawing the tree. So that's my thought process. Nala, you had something to add or something different? Go ahead. Go ahead. You're confusing the 0 power. This is something you're going to learn 2 lessons from now. 4 to the 0 power equals 1. 5 to the first power equals 5. Anything to the 0 power equals 1. Any number to the first power equals the number. Think of what Fancy said. The exponent tells you how many numbers to write down. If there's a 1 there, that means write it down 1 time. Okay? Does that make sense? Good. Any other comments, questions? Okay. Now, there were some people who got number 1 wrong. And it was a little bit tricky for one reason. 77 is not divisible by 2, 3, 4, 5, 6, 9, or 10. What is it divisible by? Oh, a whole bunch of people know. Amani? How'd you know it was divisible by 11 when I never taught you any rule? Oh, so you just know what it is. Good. Is there another way we can do it? Tristan?
Because if anytime you do 11, like the 11 through 9, 11 times 1, like the 1 digit would always the number that you use.
Okay. I understand what you're saying. I'm not sure if other people do. Go ahead, Annie.
What he's saying is like if there's 11, you do the 7 times the first digit, and then 7 times the second.
Okay, but you're saying it's divisible by 11. You're like basically saying it's divisible by 11 because 11 times 7 is 77. But is there another clue there? You've already said it, but you're not really saying the real reason. Let's do it this way. Could someone give me another number that's divisible by 11, just off the top of your head? Catalina?
99.
99. Could someone give me another number that's divisible by 11? Cameron? 33. Give me another number that's divisible by 11. Tatiana? 66. Other than these being divisible by 11, what else do they all have in common? Alexis? Yeah, the digits are the same. So that's what Tristan was sort of trying to say, but he skipped over. And then Annie was also trying to say, but skipped over, is that the digits are the same. If it's a two-digit number and the digits are the same, it's divisible by 11. Also, what they were saying, excuse me for a moment. What Tristan was pointing out is that once you figure out it's divisible by 11, it will be 11 times that number that will equal 77. So 11 times 6 will be 66. 11 times 3 is 33, and so on and so on. Okay? Anyone have any comments, questions about that? No?
Is there room for like the numbers after when you multiply 11 that's past 9, like 1 to 32?
Why don't you write down a few of them, see if you can come up with the pattern. Okay? Just do a few of them and it'll start to make sense to you. Okay? Good. So, any other comments, questions? Yes. Go ahead. Okay.
If you do 154, that's 14 times 11, 1 plus 4 is 5.
Okay. It's interesting. 2 is the middle number, yeah? You're right. Yeah, I'll do myself. I'll write down all of them, see if that works for all of them. That's a good idea. Okay. So, the title of today's lesson is Simplifying Fractions. That might freak you out a little bit. Might not be what you want to hear, but if you're patient for just a little while, you're going to see that it's actually not what you think it is. As I've been telling you, we are now in 8th grade math, and in fact, we are trying to prepare for Algebra 1 honors. And so we are dealing with some algebra concepts and skills. They fall into pre-algebra and algebra. I asked you to do the warm-up in a particular way on purpose, and you're going to see how it plays into today's lesson. So first of all, a couple of ideas. Equivalent fractions. Fractions that have the same value. I want to talk about the word value yet again to make sure that we're all clear on what I'm talking about. And I'm going to go back to the same analogy or example that I've been using since the beginning of the year. That's the example of money. So I need a volunteer to give me one way, using common forms of money, to construct a dollar. The way to construct a dollar. Kelsey? 4 quarters. Good. Can I have another way to construct a dollar, Kiara? 100 pennies. Now, I want you to think about this. I want you to close your eyes, and I want you to make a picture of 4 quarters in your mind. And now I want you to make a new picture of 100 pennies in your mind. Okay? They should look totally different. I mean, think about it. One is 4 objects. One is 100 objects. That's a dramatic difference. And yet, they have the same value. Because if I want to go buy something, they have the equivalent meaning. To the cashier or the person who's going to sell me something, 4 quarters and 100 pennies has the same meaning or the same value. It will get me the same thing. So that's what we're talking about when we talk about equivalent fractions. They look different, but they have the same meaning or value. Okay? So that's one objective, is to understand and deepen our understanding of equivalent fractions. The second and bigger goal is simplest form of a fraction. A fraction is in simplest form, and it's only in simplest form if the top and the bottom have no common factors, except for one, which we don't really count. So there cannot be any common factors between the top and the bottom.
Can we also make the fraction in the simplest form of the top and bottom are both prime?
No, because one of them could be prime and one of them could be composite. So, for example, and it's a good thought, but 3 over 50, 3 is a prime number, 50 is not, but that's in simplest form. Okay? But it's a good thought.
I think both of the top and bottom are
Well, that's what this means. They have no common factors. So that's the key. No common factors. And we don't count the factor of 1. All right, so let's see what we're talking about, and let's see how today's warm-up and the way I asked you to switch things up plays into it. So let's just start with basics. And again, try to stick with me through the basic stuff because you're going to see it's going to get complicated pretty quickly. So write 12/45 in simplest form. Now you should have been doing this for a couple of years already. So we're going to do 12 over 45. Can someone give us an idea of what we could do to put this in simplest form? Something that you've done in the past. Got 2 people who have an idea? 4 people? Okay, David, go ahead and start us off. Why by 3? Very good. That was a really well thought out answer. If we divide the top and the bottom by 3, 3 is the greatest common factor. What that means is 3 is a factor of 12, 3 is also a factor of 45, and that's the greatest factor they have in common. So if I do 12 divided by 3, I get 4. And if I do 45 divided by 3, I get 15. And so in simplest form, I get 4 over 15. And that's what I was looking for. There are no more common factors between the top and the bottom. Does anyone have any questions about that? Here is the hidden part that your teacher skipped over that now I am going to ask you to explore. We're going to do this a slightly longer way, not because I want you to do it a longer way, it's because I want to illustrate something that we're going to need in a few minutes. So now I want you to do what you did during the warm-up. Let's start with the 12. And what I would like you to do is think about 2 numbers to split the 12 into. So I'd like you to split the 12 for me. Go ahead, Catalina. 3 times 4. Put those 2 numbers in your head. Are they both prime, or can we split any of them? So raise your hand and tell me. Angela? Which one? What can it be split into? 2 and 2. So now, in your mind, you've got 3 numbers floating around. 2, a 2, and a 3. Now, none of them can be split, so now write out the prime factorization of 12. We didn't use a tree, because if I had to come over here and do a tree for this, then I'd go nuts because it's way too much work to do, because now I'm going to have to do the 45. So what I'm trying to have you see is that you can do all of this without the actual tree being drawn. Now let's do the 45. So split 45 for me. Stephen? 5 times 9. Very good. Kiara, are both of them prime, or can we split any of them? Which one? Into what? 3 times 3. So now in my head, I've got this. 3 times 3 times 5. That's the prime factorization of 45. So I've got the prime factorization of 12 on top, prime factorization of 45 on the bottom. Anyone know what we're going to do now? Got two light bulbs going off? No other light bulbs yet? Adriana?
Well, you're gonna cross out the factors that relate to the top and bottom.
So what should I cross out?
3 and a 3.
Yeah, now you cancel. There's a 3 on top and there's 1 3 on the bottom that are the same. You can cancel them out. Can I cancel anything else? No. Put back whatever's left over. 2 times 2 is 4. 3 times 5 is 15. Simplest form is 4 over 15. And so we get the same result whether we do divide the top and the bottom by the greatest common factor or if we do the prime factorization. Either way, we get the same result. But when we do this, one method is going to work much better than the other. So I am leading you towards this, and so you have to stick with me and understand why we're doing what we're doing. So this is something that you need to be able to understand. Tristan, go ahead.
Is it like the long one I guess I know this was one of the greatest
Yeah. That does tell you what the greatest common factor is because you take all the numbers that are in common on the top and the bottom, and that becomes the greatest common factor. I'm showing you a slight variation of that. Okay? Good. Let's try it again. Part B, but this time instead of doing the greatest common factor, now we're going to do the prime factorization on the top and the prime factorization on the bottom. I am asking you to do it a slightly longer way, but there is a payoff at the end. What could we split 40 into? DeAndre?
5 and 8.
5 times 8. Very good. So put those in your mind. Don't let them go away. What else can we split? Right now we've got a 5 and an 8. Savannah?
wait, what do you mean? Like another way to simplify 40?
No, we've got a 5 and an 8.
Oh, 4 times 2 to equal 8.
That's right. So the 8 can be split into a 4 and a 2. Are we done? Cameron?
2 times 2 equals 4.
That's right. So what do we end up with? Let's see who's able to store all that information in their brain. What do we end up with? Catalina?
5 times 2 times 2 times 2.
That's right. So 2 times 2 times 2 times 5. And if I'm uncertain, I can check. 2 times 2 is 4. 4 times 2 is 8. Times 5 is 40. So I know I did it right. What about the 64? What two numbers can we split the 64 into? Tatiana? 32 times 2. Let's be creative about this. Could someone remind us, this right here, what did that equal? Someone remind us, what did that equal, Stephen? 8. So if we can find an 8 somewhere, we already know what it will split into. So is there another way we could split the 64 that might make our lives easier? Natalie? 8 times 8. So now I know that if I have an 8, I can replace it with 2 times 2 times 2. So now I have 8 times 8. I can do 2 times 2 times 2. And then I have the second 8, which is also 2 times 2 times 2. And so I saved myself a little bit of effort by just using 8 times 8. And now we can cancel. One number for one number. 2 cancels this 2. That 2 cancels that one. That one cancels that one. Whatever's left over gets multiplied back together. The only thing left on top is a 5. On the bottom, we have 2 times 2 times 2. We've got 8. 40 over 64 is equal to 5/8. Does anyone have any comments or questions on how we did either of these? So now we're going to go to a checkpoint, and you may use either method. You may use greatest common factor, or you may use splitting it into its prime factorization. Either way. Checkpoint number 1, write 36/90ths in simplest form. 2 minutes. What'd you get? Oh, we got a lot of confident people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. Alexis, Savannah, Tatiana, and then Kiara. What'd you get?
2 over 5.
Okay.
2 fifths.
Okay.
2 over 5.
Okay, the same.
2 over 5.
So 4 people got 2 over 5. Correct answer is 2 fifths. Give me a thumbs up if you got that correct. Good. Put your thumbs down. Anyone have any comments or questions? All right. So that was the first goal. Second goal is the idea of equivalent fractions, and we're going to do one example, and it's going to go super fast. Write 2 equivalent fractions for 3 fifths. This is a common type of question you're going to be asked. So we start out with the number 3 fifths. How do I find an equivalent fraction? In other words, something that looks different but has the exact same value, just like what we did with money. Malak? Beautiful. Could you pick a number for us?
14.
Good.
You want me to use your number?
Sure, 2. Very good. So if you multiply the top and the bottom by 2, you have to multiply by the same number. 3 times 2 is 6. 5 times 2 is 10. 6 tenths has the same value as 3 fifths. Could someone pick another number for us to multiply by? Cameron?
5.
5. So if we multiply times 5, 3 times 5 is 15. 5 times 5 is 25. Looks totally different, but it has the same value. Could someone give us a creative, thoughtful way to prove that they all have the same value without doing anything with the fractions themselves? Chelsea? Yeah. Take out a calculator, and I can prove it to you. 3 divided by 5, we already know is 0.6. 6 divided by 10, 0.6. 15 divided by 25, 0.6. That's what I mean by they all have the same value. Does anyone have any comments, questions, or concerns on equivalent fractions? George?
I just looked at it and thought of like the easiest number to get to. Like I just got a 5 and then 10.
Okay, good. So let's see how you do on your own with that idea. Checkpoint number 2, write 2 equivalent fractions for 1/9. So we got 2 minutes. We don't need 2 minutes. Take a minute. All right. For this question, I don't have an answer to reveal because there's infinite possibilities. So let's get some of the possibilities. What'd you put? Start with Angela, and then we're going to work our way across. Angela, give me one.
8 over 72.
8 over 72. Yep, that is equivalent. Kiara? 2 over 18. Very good. Make sure you give me one that's not already up there. Annie? 3 over 27. Very good. Give me another one. Alexis? 4 over 36. Give me another one. Savannah? 9 over 81. Stephen? 5 over 45. David? 17 over 153. That's 90 and 63. Yep, that works. George, Dolly, Tatiana. George? 6 over 54. Nolly? 12 over 108. Tatiana? You said yours. Anyone have another one? Essence? 10 over 90. Very good one. So here we have a huge variety of numbers that look totally different, but they all have the same value. Does anyone have any comments or questions on this? So that was all the easy stuff of the day. Let me rewind for a moment. We started out by simplifying fraction, and I introduced a new idea of breaking it into its prime factorization to look at what we could cancel out. Then we explored equivalent fractions. Now the real work of the day, the algebra. How do we simplify a fraction that has variables within the fraction? Okay, I apologize. So, the good news is that you already know everything we're going to do. You already know everything we're going to do. Now we just have to actually do it. If we go back to today's warm-up, we discovered that the connection between this exponent and how to write it out was that this exponent tells us how many times to write the variable. So it's no big deal to change the way this is written. We have also spent time today going over how we can mentally split up a number like this. So now apply this idea to this. So let's start with the top. What if all I did was ask you to write the prime factorization or write that in factored form? Let's start with that. Start with the number, the 14. What could it be split into? George? 2 times 7. So we're going to write down 2 times 7. But now the rest is easy. You should now understand what we're going to write for this. What are we going to write for x squared? What are we going to write for that, Natalie? Very good. X times x. And now there's only one y, so we just have to write 1y. If that's all I asked you to do, that wouldn't be a big deal. But there was another part. There was a denominator. So now we're going to do the same thing with the denominator. Draw the fraction bar. Now we're looking at the 35x to the third. Start with the number. 35 can be split into what, Tatiana? 7 times 5. So write down 5 times 7. All I'm doing is writing it from smallest to biggest. Now the x to the third. How can we rewrite that? Savannah? X times x times x. Now do exactly what Adriana explained to us, earlier when it was just numbers. Cancel out 1 for 1 anything you see on the top and the bottom. The 7 cancels the 7. This x cancels this x. This x cancels that x. Whatever is left, you put back together. 2y is 2y. 5 times x is 5x. And now we have written this fraction in simplest form. Does anyone have any questions about how we did that? All right, let's see if we can do it again in part B, but let's see if we can go a little bit faster. 9a, what will that be rewritten as? Let's see who can do it all in one step. Chelsea? 3 times 3, that's the 9, times a. Very good. What about the 15x squared? What will that be rewritten as? Tristan?
3 times 5 times x.
Very good. 3 times 5 times x. Cancel 1 for 1 anything you see that's on the top and the bottom. This 3 will cancel this 3. That's it. There's nothing else to cancel. So 3a over 5, and now there's 2 x's, but now I'm going to put them back together. That's now 5x squared. And so that is simplest form. Does anyone have any questions about that? Kiara?
I remember that, like, when you said, like, when we're doing numbers, like, when there's a whole bunch of numbers, you put, like, for example, 3 cubed, but, like, for 5x squared, you don't have to, like, you can do this one for that.
When we're putting it back as a final answer, that's when you want to use the exponents. And think of the word simplify. We want things to be simple. And exponents is a simpler way of looking at something than expanded like this. Okay? So we start out this way, expand it, and then put it back that way at the end. Okay? Good? Good question. Part C. So now we need to split the top up, and then we need to split the bottom up. What can the top be split up into? DeAndre?
2 times 2 times 2 times 2 times n.
Perfectly said. 2 times 2 times 2 times 2. That's the 16. Times m, because there's one of them, times n, because there's two of them. What about the denominator? What will that be split into? Savannah? 2 times 2 times 7 times n. 2 times 2 times 7 is 28 times the 1n. Now cancel anything that's on the top and the bottom. This 2 cancels that one. That 2 cancels that one. That n cancels that n. And now put back together whatever's left over. 2 times 2 is 4. There's one m and one n. M, n, over, and there's just a 7 on the bottom, and that is simplest form. Does anyone have any questions on how to simplify fractions that have variables in them? Any questions? Okay, checkpoint number 2. Let's see how you should say, oh, it's number 3, I'm sorry, checkpoint number 3. So you got 2 minutes. All right, let's see what you got. What was your end result when simplifying this complicated looking expression? We'll start with Essence, Natalie, Chelsea, and then Annie. Okay. You agree? You agree as well?
13t over s.
I have 4 people who agree that it is 13t over s. Are there any comments or questions on checkpoint number 3? Give me a thumbs up if you got it right. Put your thumbs down. Wow, that's pretty impressive. Draw a line across your paper. Your classwork is page 187. You're going to do numbers 17, 19, 25, 27, 31, 33, and 35. That is 7 questions. You got about 10 minutes. Any issues, concerns, confusion, problems, questions, anything at all? Just raise your hand and I will come to you. All right. Colored pens up, and let's see how we did with today's complicated algebra. Numbers 17 and 19, you could have a zillion different answers. So as long as yours are equivalent, and you can double check by just using your calculator, these are suggested possibilities. You may have had something totally different. Number 25, every other question has to be what is up here. Number 25 is 4/5. 27 is 12/19. And 31 is 9CD over 4. 33 is 3 over 5W. And 35, 77x squared over 6. You've done 7 questions on your own. If you got a 5 out of 7, that's approximately a 71%, and that would be a decent starting point. And then you try to improve as you do tonight's homework. Draw a line across your paper. Your homework is page 187, numbers 12 through 36 even. That's 14 questions. And you will have a quiz on chapter 4 next week.